In this video, we're going to look at both the order of operations, and then we're going to apply the order of operations to expressions that have variables within them. So before we dive into the order of operations, we're going to take a look at what a variable is first, and a couple of key things that you need to know about variables. First, a variable is represented by a letter, and this can be any letter. Most commonly, you'll see probably X and Y, but this could also be A, Z, M, L, T, whatever you want it to be. So a variable is represented by a letter. A variable is what's known as an unknown. Essentially, we don't know its value yet, or we don't know its value right now. Eventually, there will come a time where the value will be known and the letter will be replaced by its actual value. But for right now, we're basically using that variable value as a placeholder. That's pretty much what it is. A variable's value, based on its name, may also vary. So depending on the situation, the value of, let's say we used X, could be 5 the first time, 3 the second time, and 8 the third time. It can vary depending on how that variable is being used. So at the top of the screen, you're going to see that we have an expression that contains 3 different variables. And if we want to evaluate this expression given different variable values, our first step needs to be a substitution of what those variable values are actually equal to. So if we know that X is 3, we're going to replace X with 3, we're going to replace Y with -2, and we're going to replace Z with 5. And then from there, we will actually evaluate it. So here we have 3 times X I know is equal to 3, plus 4 times Y I know is equal to -2, and then minus Z, which is equal to 5. Now, if you're like me and you don't like subtraction and you like to use keep, change, changes instead, you can do a keep, change, change here. So this would really be 3 times 3 plus 4 times -2 plus a -5. And then from here, we know that multiplication comes first, and we go from left to right. So we end up with 9 plus, this becomes a -8 plus a -5, and then we would evaluate from left to right. So 9 plus a -8 is 1, and 1 plus a -5 would be -4. So again, we just substitute in those values and then evaluate according to the order of operations. Then this next one down here, we're going to evaluate in a different combination of values, and this is where you can see that the variable's values vary. So here we have 3 times X is -5, plus 4 times Y is 4, minus Z, which is a -4. So notice how I have minus -4. Now again, I'm going to use keep, change, change here in order to make my life a little easier. So here I have 3 times -5 plus 4 times 4 plus, this becomes a plus, which is 4. So then from here I evaluate from left to right, so I have -15 for that multiplication, and then this one becomes a +16. And then we do addition and subtraction from left to right, so this becomes 1 plus 4, which is 5. Now, if you want formal notes written out on this, where do the variables fall in the order of operations? The substitution is first. So the first thing we do is we go through and we substitute in any variable values that we have. So for example, here I can see that X is equal to -4. So as I tackle this particular problem, I'm going to replace every X with 4. So I have 8 times 4 plus 3 times 4 squared minus, then I have 5 minus 4. So then from here, once I have that variable substituted in there, then I can apply my order of operations. So this is where I start with parentheses. So I then have 8 times 4 plus 3 times 4 squared minus 5 minus 4 is 1. I then am going to use keep, change right off the bat to make my life easier. And then I'm going to continue applying the order of operations with my exponent coming next. So here I have 8 times 4 plus 3 times 16 plus a negative 1. Then I apply multiplication and division from left to right. So we get 32 plus 48 plus negative 1. These two added together, well, the 30 plus the 40 becomes 70. The 2 plus the 8 becomes 10. So we end up with 80 plus a negative 1, which then added together gives us 79. Then from here we can apply that same exact process. We see here that k is equal to 3, and so if order of operations apply, the substitution comes first. So we end up with 3 squared minus 1 over 3 plus 3. Then from here, remember, if we have a big fraction, there's really imaginary brackets or parentheses around them, so we solve the numerator and then we solve the denominator. So if we apply the order of operations in the numerator, we do that exponent first, so we have 9 minus 1. I'm going to use keep, change here to turn that into a plus negative 1. And then my numerator becomes just 3 plus 3 is 6. So then from here, 9 plus negative 1 is 8 over 6. And if I simplify my fraction, I end up with 4/3. So with the order of operations, variables come into play. We start with that substitution, and then we evaluate from there.